Thank you for your patience. Thanks for coming to my talk. Finally, the 5 minutes are just great because I don't think I have enough material for 45 minutes. This will just make it perfectly on time to finish. My name is Iulian Dragos. I'm going to talk today about a few things that you should know about the Scala compiler. I've been working on Scala for probably since 2004, so do the math. I worked on the 2.0 release, which sounds a bit unbelievable now, but there was a 2.0 release. And afterwards, I worked at Lightband for the Scala IDE for Eclipse. I believe that's how it was. The full name was Scala IDE for Eclipse, to avoid confusion with other IDEs. And for the past year and a half, I'm working on a compiler called Hydra, which is a parallel Scala compiler, but more about that later. So I guess Scala, a bit more than other languages, require us to think in terms of what the Scala compiler would do from time to time. And one of the reasons is that compilation in Scala can be slow. It's not always slow, but it can be slow. And that usually depends on what kind of programs we're writing. Oh, and I should not forget, the second part of this talk is going to be a quiz, so make sure you have your phone ready and you're connected to the internet. We'll see then who paid attention. I think that's the perfect antidote to the effect of having lunch and then working straight into a talk about compilers. All right, the first thing is actually quite obvious, but I think most people complain about Scala build times, thinking that it's really the compiler that's slowing them down. But build time is not really compilation time. And SBT is in the example in this case, but take any build tool, and there's a bunch of things that happen every time you use it. So before even getting to the compiler, you'll have to do some steps, like dependency resolution. So on the right side, you see a screenshot of SBT compiling itself. So it will do dependency resolution, which says, well, I have these libraries that I depend on. Let's see if they changed, or if the versions that I have are up to date. You might have source generators, maybe protocol buffers. They need to generate some Scala code. Those are usually not the fastest things on the planet either. You might have a formatter. In this example, the formatter even printed a very useful message saying search state exploded around line 177. That cannot be good, right? It exploded. So probably time is going in there also. So I don't know if you want to format your sources every time you compile, but certainly this project does it. Then there's all the settings graph evaluation. That's not as fast as you might think. Then let's say we've done all these things and we start to compile. So SBT will try to be really smart about what it compiles. So first, it will try to find out what changed since the last time. So caching, obviously. It will go through your class path. It will go through your sources. It will hash them all. But that means a lot of input-output. Depending on your file system and operating system, that can, and of course, the size of your project, that can actually mean seconds. It can take a lot of time. Then all this analysis that is loaded and saved on disk needs to be loaded and compared. So if the project is large, this can also be a number of seconds. Now finally, SBT starts calling the Scala compiler and it starts compiling. Because it extracts additional information about what file depends on what, it will slow down the regular Scala compiler. So it needs to register or call back into its components whenever some dependency is detected between files. And actually, it's much more fine-grained than just files. So that's overall 15% overhead. I've seen lower, I've seen higher numbers. But that's roughly what you're paying. Of course, you're hoping that you would get back this time when you do an incremental compilation step, because it will detect the minimum amount of sources it needs to compile without going through all of them. Probably on the CI, though, this is just wasted time. I don't think on the CI you do incremental builds very often. What lessons can we draw from this is, I think, at least that's how I do it, I use an IDE to build. So the build tool is great if you do a release, or if you build on a command line the first time, bring in all the dependencies, format your sources if you want. But for regular development, an IDE can cut through all of those steps and just do compilation. So you'll have a much faster cycle. I think there's another tool called Bloop. So if you don't want to use an IDE, you can use Bloop on the command line for roughly the same thing. And you'll get faster feedback. All right, number two. type classes and macro derivation. This is a very powerful combination. And I think a lot of people use this day by day, daily. And one of the use cases is, I guess, JSON serialization. So you have your nice case classes, and you want to derive from them some type class, usually a JSON serializer. Well, these things can work very well, but they're also a ticking bomb. So, and one thing you have to be aware of is that you do not want to derive the type class every time you use it. You would ideally generate it just once, because if you have a case class and you have a JSON coder and a decoder and encoder for that case class, one is enough. But one thing that happens often is that you have your imports that bring in those implicits that construct the type class derivation on the spot. And you might also have one of these type class derived things in a companion object. And your hope would be that it will go and pick up that one. But actually, imports take precedence. So what the compiler will do, it will keep regenerating the same type class each time you need it, which can really explode your code size. So the cost is not only the implicit resolution time, which sometimes is slow, and macro expansion, but there's also additional code that needs to be generated afterwards all the way to the code generation phase through the compiler pipeline. So if we take one example, a case class for the full name with 2 fields, and a shipping address with 3 fields. And 2 of them are the full name. Now, when we generate a decoder for this class, or let's say we need it twice, the compiler very helpfully will generate it twice. So the code size, if I comment both decoders in there, is going to be around 8 kilobytes. So I just did a print of the ASTs after type checking. That becomes 31 kilobytes after uncommenting one of them. And if I uncomment the second one, it will double, almost double again. So why is that happening? Let's say that the compiler sees I need a decoder for this class, shipping address. I'm going to use probably shapeless to get out from the case class definition what are the components. So in this case, there are 3 of them. And says, well, I need a decoder for full name, I need a decoder for full name, and I need a decoder for string. It doesn't know at this point that they could be the same anonymous class. And then it goes down one more level, and it sees that for full name, it needs decoders for strings, and that's about it. Now, by default, what you'll get is anonymous classes for these things. Being anonymous, they can't be reused, because there's no way to refer to a decoder of full name unless you give it a name somewhere. So this will basically generate several perfectly identical decoders for full name. All right. Moving on, at number 3, we have Whitebox macros. And do you guys know what's the difference between a macro that's Whitebox and one that's black box? All right. Oh, I see one nodding head. So a Whitebox macro is allowed to introduce new types into your program that can be referred to by others. Or in other words, once you expand the macro, you might find that the resulting expression has a more precise type than before. And actually, that can help the compiler in the next steps, for example, overload resolution or type inference. Black box macros, though, and I believe this is the only ones that will make the transition to Scala 3, are much simpler concepts. Once a macro is expanded, the expression that you get has the same type as what you had before. You can't refine that to something more precise. So this is a screenshot from the actual source code of the Scala compiler. So you can easily see that the black box one is easily type checked by invoking the type checker just once, while for a white box one, it goes through 3 rounds. It doesn't automatically mean it's 3 times slower, but it does mean that it is a lot more work going on for a white box macro. And shapeless macros are white box. So I believe a lot of the ecosystem right now depends or uses shapeless macros indirectly, maybe. So you are exposed to this potential compilation time explosion because of these effects. So I keep talking about type checking and how long it takes to type check. Roughly, the type checking phase should be around 30%. Of course, the compiler will not report this to you, but what you can do if you feel that compilation times are getting out of hand is to run Scala C once with minus verbose on the command line, and it will print timings for each phase. If the type checking phase is really out of line, so let's say it's 80% of your time, then you should probably investigate and see what files are the ones that bring in either macro expansions, implicit resolutions, or generate a lot of code, and try to break them down, or potentially just make sure that you don't have the ticking bomb imports in there that just start regenerating all these type classes all the time. So yeah, I think I already mentioned, in case this happens, macro expansions are actually sometimes disguised. So there are certain features in the standard library that are implemented as macros. So quasi-quotes, type tags, some form of string interpolation, these are all implemented as macros. So quasi-quotes are actually relatively slow when you use them, if you implement your own macros, of course. So we came up with one number to sort of summarize this explosion factor, and it's the typer to parser node factor. That means if I look at my program after just parsing the source code, which is as close as it gets to what you wrote, the programming wrote, and then you look at the same tree after type checking, where all the macro expansions have happened, type inference has kicked in, and more or less the program is considered correct and ready for code generation, a few phases down the line. Now, what is this factor? Usually, it shouldn't be much more than 1. You would expect it to be around more or less 1. Well, generally speaking, type checking, but not only. For example, case classes generate a lot more code. For example, a case class has a companion object which has a copy method. No, sorry, that's the case class itself. It has a copy method. It has a lot of default parameters as well. And those are method definitions that themselves are implemented and so on. So case classes add to the code that gets generated as well. The bottom line is that more nodes need more time to type check and more coffee to drink. So typically, we see that this value is 1.2. Sometimes, interestingly, it can be lower than 1. Any guesses as to when that happens, or why would that happen? Well, it can still be macros. Macros can remove some of the code you're passing to them. But I think more often, it happens when you have a lot of explicit types. And after type checking, all of those large trees that describe the explicit type are replaced with one symbol and a type. And those they're not counted as an AST node. So it's more of an artifact of how these nodes are counted. So at number 6, we have the Scala compiler is single-threaded. And I think this is relatively a common case for many compilers. But I was surprised to talk to people yesterday, and they were actually surprised and said, no, that cannot be true. So why is that the case? Well, it's a batch compiler. It was written probably more than 10 years ago it started. And in the interest of performance and the hardware that was available 10, 12 years ago, it uses mutability. For good reasons. It makes certain things faster. And for correctness, or because of the language, it also has to use laziness in type checking. In order to allow circular references, like a class referring back to itself, you cannot be too eager when you type check those things. So laziness is required. Mutability for performance. If you put the two together, you probably don't want to add multi-threading as well. It will make for a very complicated piece of software. But I have to say that in 2.12.6, I believe in 2.12.6, not earlier, there's an experimental multi-threaded class file generation phase, which tries to use more threads when the code is generated. Because at that point, you do not have to worry about, or so much, about type checking and laziness in the types and symbols and so on. But one consequence of that is that bigger and more powerful machines won't really make a dent in compilation times. So my MacBook is from 2016. My colleague has one from 2013. We have exactly the same compilation times with Scala on every project I tried it. So unless you have a way to utilize more cores, single-threaded performance is not really improving anymore. So unless you have a parallel Scala compiler, you won't be really be able to improve compilation speeds, or you need to have some other ways of utilizing the hardware to get faster compilation. So there is one that works today, of course. That's Hydra, but that's not why I'm here. So how fast is Scala C? This is also a question that comes up, and people debate it. Is it compiling, I don't know, 3,000 lines of code per second or 500 lines of code per second? And it's really dependent on the project. So I put together a few numbers. I think the more interesting part is the relative distance between them, not the exact absolute number. These are lines of code excluding comments and whitespace. Those are irrelevant. So you might find higher numbers if you count those, but I think that's a little bit uninformative. So I said simple code, which is sort of using Scala as a better Java. And I take Spark as an example of a large code base written in that style. We've seen about 1,200 lines of code per second, average speed. If we take functional programming, sort of heavy kind of projects like cats, that goes down quite dramatically. So 480 lines of code a second, even less than half. An interesting thing to note is that a Play project has quite different compilation speeds, and I guess it boils down to the kind of code you write. So views, which are roughly HTML embellished with some Scala expressions here and there, they're quite fast to compile it. With Scala, it's 2,000 lines of code a second. And controllers, where there's a lot more logic and a lot more types involved, those are, again, on par with cats and functional programming style coding. So the numbers are with 2.12.4. I don't think there's a huge difference if you move to 2.12.6, the latest release. Correct me if I'm wrong. For LeChess, I used 2.11.11 because, the LeChess is still on Play 2.5, I believe, and that's only supporting 2.11. All right, so at this point, I will test your knowledge of Scala compilation. So take out your phones and connect to, let me see if this works. So this is, I'm taking here a bit of a risk. So you should go to the kahoot.it website and enter the game pin that you see. And I'll give you a few minutes to do that. And then we'll have 8 questions, multiple answer. And at the end, we'll see who knows the most about Scala compilation. By the way, the IDs are automatically generated by Kahoot. So I hope that they're all nice. '79 players. I didn't know the room is so big. OK, some of these, we seem to be capping at 80, 81. OK, let's start. 80 players. I think that's not bad at all. 81. Anyone having troubles connecting? Can I start? OK, let's go. So the first question should be easy. It's going to be a warm-up question. So what was the host country of the World Cup 1994? Italy, Brazil, USA, or Russia? By the way, the fastest you answer, the more points you get, if I'm not mistaken. All right, so USA was the host country in 1994. Not Brazil, not Brazil. That was more recent, I think. OK, Radiant Ferret, good job. So the next question is, how many instances of decoder of full name are generated in this code? So full name, not shipping address, right? The one up here. 1, 2, 3, or 4? We have 83 answers, but I thought there were only 81 players. What's happening? Can I close? No. I don't want to skip because I actually want to see the answers, but let's wait a bit. Let's wait another 10 seconds. All right, most people got it. So for instances, and the reason is because this recursive expansion is generating anonymous instances of this decoder, so they can't really be reused. Each one will be just an anonymous class that gets passed right there where it's needed. Good, let's see. Stellar Falcon has taken the lead. What was the most important new feature in Scala 2.9.0? So we have new collections library, parallel collections, XML literals, or triple quotes. Parallel collections, correct. New collections library is coming up in 2.13, if I'm, or there was okay. The old new collections were in 2.8.0, I think. Speedy Egret. All right, we're halfway through. How many lines of code per second does Scala C compile in a typical project? So 1,200 lines of code, 3,000, 5,300. This should be an easy one. All right. The large majority got it right. Somebody was very pessimistic, saying only 300 lines of code per second. And we also had 4 very optimistic people at 5,000 lines of code. I wish. How many lines of code? Of course. Next question, I think it was pretty obvious. Does Scala compile in a typical purely functional programming style? So 400, 800, 1,000, or 5,000. Can anyone guess, since I see all the answers are up there, where is this screenshot taken from? What library? Cats, correct. OK, so again, 4 people are consistently very optimistic, 5,000 lines of code per second. Yeah.
They might not be taking it seriously.
You think? All right, Speedy Egret seems to be consolidating the advantage and staying ahead. Which ones of the following Scala features are implemented as macros? So string interpolation, type tags, formatted string interpolation, and quasi-quotes. Well, more than one is correct here. There's not just one answer that's correct. Yeah. So there is one that's not a macro in there. There is one answer that's not correct. OK. Just plain string interpolation is actually not a macro. It's formatted string interpolation that needs to be a macro, because you want to make sure that whatever you're passing and fits into the string is actually the right type. So %d it actually takes an int, and so on. Type tags, they must be a macro because you want to reify a type into something that can be inspected at runtime by your program. And fuzzy codes, roughly the same reasons. All right. Let's go to the 7th question. What implicit is selected here? And what does this program print? So this is a minute and a half. So essentially, there are two ways to get that implicit. One is from the companion object of foo, and the other one is from the import. Correct. Most people got it. It's the one from the import. I think the confusing part is that if you're going the import route, you actually have to jump through 2 hops. So there's an implicit that needs a second implicit in order to give you the value you need, list of foo, while the companion object gives it in 1 hop. It actually has a field with the right type. But that's not how implicit resolution works. Implicit resolution takes imports as higher priority if you want. So it goes down the import route and it constructs the implicit, even though it's a more complicated, so to say, term that it creates that way than if it were than taking the one from the companion object. So, and it does compile. I checked. Speedy Egret still ahead, and Royal Elephant is actually second now. Cool. Last question: when was Scala first publicly announced? So January 20, 2004, July 1st, 2006, September 1st, 2020, so it's from the future, or January 23rd, 1996. All right. Most people guessed right. It's 2004. I guess if you actually could read the announcement email, you would see that it requires Java 1.4. So I guess it gives at least some reference point. Anybody knows what happened on January 23rd, 1996? What was released on that date? Java, exactly. All right. I think that's it. So Speedy Egret, congratulations. Yeah, come by our booth and you can get a Hydra license to speed up your compilation even more. Thanks for participating. I think it's great. I'm very glad that everyone could connect and had access to the internet in time. To summarize, I guess what this talk is about is compilation times are unpredictable. And you can often have one single file account for really 80% of compilation time. And most of that goes into macro expansions and implicit search and things like that. So compilation speed really varies according to your coding style. And then macro expansion, if used unwieldy, can really increase your code size impressively. So thanks a lot for your attention. Hydra is our product, a parallel Scala compiler that goes faster. So if you're interested in what we do, come by our booth. We're next to the Lightband booth, and I'd be happy to talk to you about it some more.